Okay, we're official. So we're going to talk, we're taking a little break today from quadratics, and we're just going to start, we're going to look at some mixture word problems. They're really not that hard. They're not that, I mean, they're kind of fun to do. I do find that when I read them, though, I don't know about you guys, but it makes my head spin, right? I don't know how to take all that information and, I mean, I do, but it's like when I first read it, I think, oh my God, how am I going to find the answer to that, right? And so to have a method to solve this is really helpful, really, really helpful. And the main thing is, as with distance word problems, when you have motion word problems, rate times time equals distance, it helped, didn't you find that it helped to have a place to put all the information, and then you knew it was this plus this equals this, right? Remember that? It was really easy. So that's the same thing we're going to do here. I managed to lose my marker. Oh, okay. So we're going to use a formula that's up here and for mixture. And it's basically the amount of a solution. So let's say I had a 20% sugar solution, all right? Okay? Let's say the amount of the solution is like 2 gallons, right? I have 2 gallons of sugar solution. And it's a 20%, 20%, 0.2%, or 0.2, right? 0.2, well, I'll just say 20%, that's fine. 20% sugar. That's what this is, right? Well, to find out how much sugar is in here, all I have to do is multiply my amount of my solution times the percent of my ingredient. In this case, it's sugar, right? Sometimes it's tang, sometimes it's acid, sometimes it's, you know, cranberry juice, whatever.
What's
you know?
tang?
What?
What's tang?
Oh, you don't know what tang is?
Isn't it?
It's like
Do
that.
they have like the gorilla or something?
When I was growing up, God, they don't have tang anymore? I can't believe it.
Like not very popular.
Yeah.
It's like
It's like an orange powder that you put in water and you mix it,
Oh,
and it's good. What?
kind of tastes like
Is
Fanta.
it?
is it Kool-Aid?
It's sort of like Kool-Aid.
It's like
It's like Fanta, but
yeah.
not carbonated.
It's what?
exactly
It's like Fanta, but not carbonated.
Okay.
So it's like orange Kool-Aid.
It's like orange Kool-Aid, sort of. Yeah.
My mom is like always talking about like the soda that she had as a kid, and it's like really weird. She's like obsessed with it. She's like, I remember Squirt.
Yeah. Okay. So if you have 2 gallons of a solution that is 20% sugar, and I multiply it times the percent of the sugar, which is 20%, if I multiply it times 0.20, right? That doesn't look right. If I multiply it times 0.20, it equals the amount of the sugar that I have. So I would have 2 gallons times 0.2, okay, that would be, I would have 0.4, that would give me 0.4 gallons of sugar, right? You see what I'm saying? It makes a lot of sense. I have my amount of my solution times the percent of the ingredient, whatever it is, sugar, right? And that'll give me my amount of my sugar. That's really a useful formula. So what we're going to do is we're going to create a box. Let's see here. I just want to be sure this can be seen. Okay. So here we go. We've got a box, and it's going to be 3 rows and 3 columns. Okay? So we're going to have amount of solution, and that's this column. And then we're going to have percent. In this case, it's percent of what? Acid, right? Percent of acid. And in this case, it's going to be my amount of acid, right? My amount of acid. Okay? Like acid or something. Okay, and then I have 3 rows. And what I have, let's just look at this. I have mad scientist. A mad scientist has one solution that's 30% acid. So my first solution is 30% acid. 30%. So I'm just going to write 30% there. That's the 30% solution. So you, Henry, you're going to have to write this down. You can't do this without writing it down. again?
What is about solution?
Amount of solution, sorry. Whoops. Whoops. Does that work? See it? Okay. Yes, but come fast because you're missing it, right? 30%, we got one that's 30%, and then the other one is 18%. That's my other solution, right? 18%. Now, what is the final thing, do you think? How much of each should he use to get a 300 liters of a solution that is 21% acid? That's a mixture, right? He's mixing the two together. So your bottom row is a mix. Okay, that's my mixture. Okay? So now we can just start filling things in. It says mad scientist Nate has a solution that's 30% acid and another solution that's 18% acid. I'm curious about amount of solution for a second. So I'm reading a little further. How much of each should he use to get a 300 liter solution, right?
Would that be half?
Where would that go in this? That's the mixture, right? Isn't that the mixture? We're going to add them together to get 300 liters
That
of
should be
something.
on the mix, right?
So that's going to be the mix, right? That's my 300. You with me? So my amount of my mix is going to be 300 liters. That's pretty clear, right? The thing that's not clear is this part. I don't know how much of this to put in, and I don't know how much of this to put in. But there is a rule. Remember, I've said this a few times. If the sum of two numbers is equal to, say, 10. Just remember this. If this, okay, the sum of two numbers is 10. The first number is always x, right? Because we don't know what it is, right? Well, what's the second number? Okay, no, but we're going to use it in using x with it in terms of x. What? 10 minus x. It's whatever's left over when you subtract x from the total. Does that make sense? If the sum of two numbers is 10, first number is x, and the second number is whatever's left over when you take x away from the total. Right? It's not x minus 10, it's 10 minus x. It's the total minus the x. All right, so if the sum of two numbers is 300, what would it be? X and 300 minus x, right? You with me? Okay, so we know the total of these two is 300, right? Does this make sense? Right? We know that this plus this equals 300, therefore one of these has to be x. It doesn't really matter which one. I'm going to make this one x, and I'm going to make this one 300 minus x. So, Allie, you kind of missed an important part, so you're going to have to watch this video. And then percent, so does everybody, fist of 5, do everybody understand how I got this? Everybody get it? Okay. Now my acid, this is the easy part. The percent acid is right here. It says 30%. How would I write that as a decimal? 0.30, right? Or 0.3. And then 18%, 0.18, right? 0.18. And then what do I put here for my mixture?
Would it be 21?
Yes, because that's part of my mixture. I want to get a 20% acid, so 0.21. Now, remember my formula up here. So Henry, you writing this down? I want to see it. Okay, good. So here's my formula. It's the first column times the second column equals the third column. So now that I've got the two columns filled out, it's really easy. All I have to do is multiply, right? So that times x is just 0.3x, right? This times this, I like to just write it as this. 0.18 parenthesis 300 minus x. I don't like to figure it all out right here. I just like to write it clearly like that. Does that make sense? And my last one is just 300 times 0.21. I probably should have figured that out, but I didn't. So, how much time do I have? Okay. Where am I? 300 times 0.21 equals 63. Okay, so the beauty of this thing is now we know exactly what to do. We have the amount we want. We're trying to get 300 liters of something that has 21% acid. So, and we're gonna take the amount of acid from this solution, add it to the number of, the amount of acid to this, of this solution, and get 63. Does that make sense? So it's gonna be this plus this equals this. Pretty straightforward, right? So all I have to do is 0.3 x plus 0.18 times 300 minus x equals 63. So 0.3x plus 0.18 times 300 equals 54. So plus 54 minus 0.18x equals 63. Now, oh, I could have done one thing. If you don't like working with decimals, do you guys remember this?
Or you multiply everything by
I could have multiplied everything times 100, right? And then I would have had 30x, 18 times this equals 6,300, right? Remember that? That might, do you want me to do that? Is that easier for you guys? Then you don't have to deal with decimals. It's up to you.
Then you're dealing with super big numbers.
Well,
like
could we do that on the next
6,000.
one?
What?
Could we do that on the next one?
We can do it on the next one, so
Yes,
that's
we can,
fine.
like,
It's
examples.
fine to use it as decimals as well. Okay, so we can do 0.3 minus 0.18, so 0.3 minus 0.18 is equal to 0.12. So we got 0.12x plus 54 is equal to 63. I'm going to subtract 54, subtract 54. 0.12x is equal to 9, right? Right? And now what do? I'm just going to divide both sides by 0.12. By 0.12. So I've got 9 divided by 0.12 is equal to 75. 75. So x is equal to 75. Now what? 75 what? What is x? X is my amount of my solution. I can always go back and see, well, what is x? Oh, so I have 75, we're talking liters, right? So I have 75 liters of the 30% solution. This is awesome. We got our answer, right? So what's the question? How much should he, of each should he use? Okay, you know, he needs 75 liters of 30% solution, and he needs 300 minus 75, which is 225, right? Right? And he needs 225 liters of 18% solution. And we're done. We got it. Make sense? Right? Just to 5? You get it? Pretty straightforward, right? You missed a key part. If the mixture is 300, right? Then 300 liters, then the first one number is going to be x. The other one is whatever's left over when you take that x away from 300. So x and 300 minus x. So if the sum of two numbers is 20, first number is x and the second number is 20 minus x, whatever's left over, right? See what I mean? All right, that's it. That's what you missed. Okay, so I'm going to erase this. Can I erase it? You guys all get it? Did you get it? Did you write down the equation? Did you write this part down? Write that part down. I'll leave that in there for a second. I've got 2 more to try to do. Squeeze it in. And I don't know if I'll make it. I'm going to try to just use, oh, shoot. Oh, forget
Gary,
that
what
idea.
time are we like out of this class?
What?
What time does this?
I think it ends at 5 of. And then I'm going to leave that for a second. So my next one, just because you'll see that there's different like things that show up, and I just want you to be prepared for them. So this one is actually much shorter. How much water, so please write this as I'm writing it. Okay, how much water should be added to 800 milliliters of a 5% sugar solution to get a 1% sugar solution. Okay, so I'm going to do my box again. This is my amount of solution. And this is my percent of sugar, right? In this case, now we're talking sugar. Percent sugar. And this one is percent, amount, sorry. It's amount. Amount of sugar. And then I have 3 rows. So, okay, how much water? So I've got water here. I also have 5% solution. And then I have my mixture. You guys see how I'm setting it up? That make sense? I've got water, I've got a 5% solution, and I've got a mixture. So now I got to fill in my boxes. How much water? We don't know, right? We don't know how much water. I'm going to make water X. Is that okay? All right. How much water should be added to 800 milliliters of 5% solution? Where does 800 milliliters go? Right there, right? That's the amount of the 5% solution that I have. Okay? And then what would my mix be? Wouldn't it be this plus this in this case? Wouldn't I be adding these two together? Right? So it's just x plus 18, right? I mean, plus 800, sorry. Right? Does that make sense? Okay? And then now I can do my percent. It says how much water should be added to that, to a 5% solution. I know my 5% is what? 0.5?
0.05.
Ah, 0.05, good. 0.05, right? Now how much sugar is in water again? Right, I mean, hopefully your water doesn't come out with sugar in it, right? I don't know about, hopefully, right? You turn the water faucet, it better not have sugar in it, better not. They might try that though, you know, to try to control us. Conspiracies, no, right, okay. So we got 0%, right? 0%, right? Or 0, right? There's none, right? And so, and then how much do we need here? We need a 1%, right? 0.01. You with me? So now we just multiply it out. 0 times x, let's see, multiply to carry the 1. Okay, 0, right? Beautiful. Okay, now 800 times 0.05. 800. Somehow I got more stuff in here. Okay, 800 times 0.05 equals 40. So that's 40. And then this one, I'll just do 0.01 parenthesis x plus 800. Okay, so now I can erase this. This time I'll do it the other method where we multiply times 100 so you can see that. So now I have this plus this equals this, right? Pretty straightforward. This plus this equals this. So suddenly I have 0 plus 40 equals 0.01 times x plus 800, right? So that's really just 40, right? Now, so it's really just 40 equals 0.01 times x plus 800. Now, I could multiply this out as 0.01x. Now, the other way I could do it, I said I would show you this on the next one, is you could multiply, just to get rid of the decimals, what would I have to multiply this by to move the decimal 2 over? 100, right? So I could multiply this times 100 and this times 100, right? So I don't have to multiply this times 100 because this is being multiplied times this and this will be multiplied by that, right? So I don't want to multiply this stuff by the 100. It's like 100 times this and 100 times that. So suddenly, what's 40 times 100? Yeah, I'm going to add the zeros. There's 3 zeros, so it's going to be 4,000, right? Equals, now it is, I'm moving this over, it's just a 1. 1 times x plus 800, yes. Right? You with me? Now that makes it kind of easy, because 1 times that is just that. So suddenly I have 4,000 is equal to x plus 800. So to find x, I just subtract 800. Subtract 800, and I will find that I need 3,200 milliliters, right? That is what my x equals. So now I'm coming over here, and I look at my box again and see, okay, my x is the amount of water that I need, right? So I need to add 3,200 milliliters of water. Make sense? I'm going to run out of time for my third one. I think I'll not do it. This to 5, you get it? Okay, awesome. There is one problem on the homework where I ask how much water, like somebody added too much water to a solution,
And
right?
how much water you can.
And how
take
much
out.
do you have to evaporate out, right? So think about it. If you did something like that, if you had water and 800, it would be 800 minus x. How much would you evaporate, take away? Your mixture would be the 800 minus the water. Do you see what I'm saying, the difference? That's how you would set those up. Okay, that's it. So I'll turn this